血运没有学过 ，OK， 这个很重要啊，很基础的。因为你学结构动力学，也两种振动一定会有这个东西啊。不然是要解PDE 就是有时间跟位移的，就这样解振动问题。I'm going to retire, but otherwise I want to design new course, structural vibration. It's very important. We'll get more and more vibration power in steel structure. A lot of things, yeah. Signal processing and vibration equation solver. And all the phenomena, physical meanings is very, very important. I will try. Okay, it's good. Maybe a good job for me to, after retiring, I can write a book or create a lecture, maybe a talk in NTU Taipei in National Taiwan to see if I can apply a job there as an adjunct professor.
Professor, do we have another mechanic major professor like you? I mean, here in NTU? If you retire, so who's gonna teach our kind of course?
That's a tragedy of our department. They have no vision to help. Yeah, I give up. Okay. I did a lot of political stuff. So. Actually, right now the problem in Taiwan is not many professors like me. No mechanics. Right now they hire new professors. I always be the the reviewer for the professor in NTU. What they want is AI, artificial intelligence, or structural health monitoring of things. But recently they hired a guy as a practicing from NCKU, but that guy is too theoretical. So the problem is not many universities in Taiwan teaching mechanics. That's a tragedy. So that's why I spend so much time on teaching you mechanics of composite. I give out I didn't teach that for 20 years, but I say I pick up. Maybe I will try to teach you somewhere. Yeah. Last week my wife asked me, what can you teach in NTU? Okay, because my wife, she's the vice president of the NTU, and she's in civil also, but in transportation pavement. So I'm a guy doing bridge. She's a lady on pavement.
Perfect combinations.
So yeah, and I did some courses like advanced material, artistic, continuum mechanics, artistic, wave propagation, and mechanics of compound material. I can take these courses, but maybe I will try to, for myself, maybe I'll try to, vibrations a lot. What recently I'm interested, because I did a lot of monitoring and a lot of vibration measurement. So we want to, from the vibration, to identify the condition of the structure. For example, right now we are doing some measurements to measure the tendon force inside the cable stay bridge. Tendon, yeah. So we want to know how much internal force there. So right now we put some accelerometer from the signal, and we time domain, we got the frequency. Okay, from the frequency we can identify the internal force. So this kind of inverse problem. Okay. Yeah, my student, Vincent Reich, he's helping. We are doing what? Parallel cable with a cross link inclined. Vincent solved an analytical solution for this. From the vibration signal, we can calculate the tendon in this one, tendon force in that. So that means in the future we don't have to take out the cross link. we can put some sensor and we can always know the internal force inside the body. Yeah. Another thing is, for example, if this is a bridge, if we put some sensor and we have a car moving through from motion, if I can identify the damage in somewhere, this is a very interesting problem. So far, I have no solution. Especially if this is a PC girder, that will be much more different. So I have to solve the analytical solution for PC girder under vibration. For different tendon force, the vibration will be different, right? The frequency will be different. So this kind of inverse problem. So in engineering problem, always three parts. One is system. Another is input. And is output. Right? So usually, professor gives you a structure and give you a loading, want to write out the diffraction, right? The problem right now is that we know the input, we measure the output, see if we can identify the property of the structure, like stiffness, mass, damping, or cracking location, or internal force. So this is a very difficult problem. Okay, you have two information to get third one. This is forward analysis, but you have these two to get input. See how much loading. For example, right now in Guandu Bridge, we install some strain gauge, and from the strain gauge data, we can know how much loading the truck every day goes to Guandu. We already done this. Okay, so now we have a loading spectrum for example, 2 tons car, how many this month, and over 110, how many this month. So we have a spectrum. So for this, we can do the fatigue-like prediction of all the structure. So we are doing this way. So this is called inverse problem. Right now in the world, most research are doing we call the inverse analysis or backward analysis. Okay, so just like a doctor, identify the condition of this patient, this patient. This patient cannot talk. Okay, he just display his vibration, his temperature, his frequency, and as a doctor, I have to get his condition from those information. So this we call the inverse analysis. But you want to be a good doctor, you have very well about this forward analysis. Okay, that today I'll give you a homework for being, if we have a damage, and then in the different material properties, see the response of this structure. Okay? Okay. All right, so this for example for the continuous loading cube. Today I'm going to show you how to solve the beam with discontinuous loading. Okay, this is the method I'm going to talk to you today. Last week, a new student come into my office, say he want me to be his professor. And I talked with him, I assigned him some problem. And before I come here, he just say, I want to change my professor, not you. I said, why? I said, do you think, are you worried about you cannot solve the problem? I don't know, maybe 他可能会问你们是不是？你晓得？
International students.
Like a new student from Jinan, very good student. He's a number 1 student in his class. 许维祥，他跟我说他换角教授了。我就说是不是你怕做不出我给你的题目？他看着他可能问你们，你们都做不出来还是怎么样？我说没有问题啊，只要跟着做就没有问题。Yeah, so. A lot of students want to learn to face a difficult problem. Maybe I'm too old to give the problem too difficult. So, but it is, I think it's very important for this method. Yeah, you have to, good at your mathematics. Okay, because a lot of theoretical mechanics are related to the mathematics. Yeah, just like today, I'm going to show you your heavy side function. Okay, heavy side function. Anyway. Another reason I think is because my students are very, how to say, picky. They have to do a lot of extra job, have many bridges. So they have to go to Hualien and a lot of places to get data for the bridge. So compared with other professor students, my students we will spend a lot of extra energy work on other things. But I think they learn something. Yeah. Like some of them already can use the Midas to do the bridge modeling. I think it's very well. Yeah. But anyway, so I have to reduce my business model. Good. All right, and today we'll talk about the beam with discontinuous. Discontinuous loop. Okay. May I call them I learned this method when I was a PhD. My professor taught me, the advanced material professor. He graduated from Caltech, California Institute of Technology, one of the best schools in the world in mechanics, right? And this method he taught me. So this also a name for the half range. Function method. Okay. Yeah. Let's give an example first. For this beam, we have a reaction force R1 is known. Okay. R2. Okay. For example, I give you a loading P. And this is A and B. So what R2? Can you tell me? R2, how much? P O A plus B A. Okay, and R1 is P over times B, A plus B. Okay, so R1 is given, right? Now we have a P loading, and the length is L. Okay, and the second